Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back once again to the Tech Talks Daily Podcast. I am conscious I throw a different interview into your podcast feed every single day, so the fact that you've tuned in once again means more to me than you could possibly know. So a big thank you for joining me. Now, as I look to invite guests onto this podcast that are leading the way, I came across an announcement that Honeywell, a company best known for making control systems for homes, businesses and planes, they reported that they had built the most powerful quantum computer ever. And the article talked about how Honeywell measured its computer's capabilities using a metric invented by IBM called quantum volume. And on hearing that, I found myself channeling my inner Doc Brown going, "Great Scots!" But seriously, quantum computing will undoubtedly revolutionise the way that we work. But it always felt to me like quantum computing was always on the horizon. But after spending more than a decade focused on ways to not only help architect this massive expansion of computational power and problem solving, but after spending more than a decade focused on ways to not only help architect this massive expansion of computational power and problem solving, but accelerate it too, Honeywell are making big headlines today, not tomorrow. So after hearing how Honeywell released their next generation of quantum computer and are collaborating with Accenture on cutting-edge quantum applications, I invited them onto the show to discuss their latest announcement and explore some of those quantum computing trends that we can expect here in 2021. But enough from me. Buckle up and hold on tight so I can beam your ears all the way stateside so I can introduce you to today's guest. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, so my name is Brian Neyenhuis. I'm a scientist at Honeywell Quantum Solutions, based here in Colorado in the United States. And I'm in charge of leading the commercial operations group here. So we operate, troubleshoot, and upgrade our commercial quantum computers, which is really fun to say because just a year ago we didn't have any. So it's been a real fun ride to set up these computers and start working with our customers and see some real value come out of them.
Excellent. And a lot of people listening will have their own perception of what Honeywell is and what you do. But before we do begin, can I ask that you set the scene and just tell the listeners a little bit more about the kind of problems that you traditionally solve for businesses with technology at Honeywell?
Yeah, so Honeywell is just an absolutely massive company. I don't think I understood half of what we did before I joined up to do this quantum computing stuff. But they're involved in all sorts of industries, doing control problems, chemistry, safety solutions, working with buildings to become more efficient. So Honeywell's all across many different industries, and I think that's sort of perhaps why quantum computing was a natural fit, is that it also has many ties into all these different things. Right, a quantum computer, I'd say its implications are not fully known yet. There's still a lot of research going on what else it could do. But there's a few dozen, maybe upwards of 100 sort of known quantum algorithms that computer scientists have proven can do things better than you can on a classical computer. And there's really famous algorithms like Shor's algorithm that factors numbers, or Grover's search algorithm. But there's also things like optimization and especially simulating quantum mechanical systems, which is what chemistry really is, right? The world is quantum mechanical, and to understand those problems in great detail, you can't just abstract away that quantum mechanical detail there. And so, sort of the solutions we offer with a quantum computer dovetail into all these different business areas that Honeywell is already in.
Incredibly exciting work you're doing there, and working with incredibly exciting technology as well. But where does Honeywell's quantum services fit into that big picture that you've just painted for us? Yeah,
so we have quantum hardware now. So we actually have a quantum computer where you can run these algorithms, which for a long time were just sort of abstract, mathematical ideas come up by computer scientists and others. but now we can actually run those algorithms on this quantum hardware. And so we work directly both with internal customers within Honeywell, as well as external customers, to sort of translate the problems they're working on into this language of a quantum algorithm, and then run it on our hardware. I would say this is still very early days, and there's a lot of learning going on. So this collaboration between our team of quantum scientists and the subject matter experts at our customer sites, we're working together with that team to sort of figure out how to best map these problems and what to run on the hardware now to inform the research going forward as our systems continue to grow. Has been a real focus of our group right now.
And one of the reasons I invited you on the podcast today was after hearing how Honeywell recently released the next generation of a quantum computer. So can you tell me a little bit more about that announcement and what it means for your customers?
Right. So at the end of October, we released Honeywell System Model H1, which has 10 qubits right now and a measured quantum volume of 128. But just because that's the specs it launched with, it won't stay static there. That's one of the fun things about trapped ion quantum computers, is that the infrastructure is there that we can continue to add more qubits and upgrade the capabilities without throwing the whole machine away and starting over. So throughout the year, we'll see those specs increase. But I'd say this was a real large jump forward in the capabilities of our quantum computers, and allow our customers to run larger algorithms than have ever been possible. I would say, although there are systems out there with more qubits than ours, they're all limited by the fidelity. So sort of how often you get the right answer instead of garbage, right? And so in classical computers, this is something we don't think of very often. The fidelities are so high that you almost always get the right answer. And occasionally a cosmic ray will come in and zap one of your transistors and an error will occur, but it's very, very rare on a regular computer. On a quantum computer, that's just not the case. These quantum states are so fragile. So really launching a system where we can run interactions between two qubits that are 99.5% accurate, or have that 99.5% success rate, the fidelity there, if you will, is really important, that we can start to run these algorithms and understand and trust the outputs that come out.
And when that announcement arrived on my news feed back, I think it was back in October, one of the things that stood out was Honeywell's ongoing collaboration with Accenture, especially on cutting-edge quantum applications. But for anyone that missed the announcement, can I let you expand on that too?
Yeah, so Accenture was listed in that announcement as one of many partners that we're working with to sort of build up, I would say, the building blocks of these quantum mechanical algorithms and capabilities of our system. So one of the really nice things about the system model H1 is, because of the architecture we use, where we actually physically move our qubits around to have them interact with each other, we can do something which currently nobody else can, which is you can measure a single qubit in the middle of a circuit without destroying all the information in the computer, right? And this is absolutely necessary as you move on and do things like quantum error correction, which we needed for large-scale quantum computations. But it also gives you a lot of immediate advantages too, even with these smaller quantum computers like we have now. And so with Accenture, we started to look at, with this mid-circuit measurement, what are some of the unique things we could do? And one of the circuits they ran on our computer that we were working with them was one where they did a quantum adder circuit. So adding numbers is something we do all the time and take for granted in a classical computer. In a quantum computer, it's still not hard, but it is a little different. And they were able to show that by using this mid-circuit measurement, they could do it much more efficiently than you could if you didn't have that capability. And so we've been working with them and other partners as well to sort of explore all of the different advantages we have because of this new feature set, and sort of build up this toolbox of ways you can use the quantum computer to build into larger algorithms that actually have, I would say, economic value later on.
And what type of applications can quantum computing be used for? And for anyone that may be outside of the tech industry, that's maybe a bit cynical about any overhyped new technologies, and maybe they've been burnt by AI or something in the past when it wasn't really AI, what additional value does it actually bring to the business?
Yeah, so I'll say that we don't know everything a quantum computer is good at just yet. I'd say there's still a lot of ongoing research, and I fully expect that we're going to be surprised by something. Some new application will come on, and quantum mechanics or quantum computers will be able to solve problems we had no idea they could. But we do know currently about a lot of things they're good at. So because the world is quantum mechanical and chemistry is a quantum mechanical process, it's very easy to see that if you want to develop new molecules or understand chemical processes, or material processes, that quantum computing is going to be a good match for that. You can simulate all the quantum mechanical dynamics of the system and don't have to abstract that away. One of the problems we see with classical computing is to store all the information you need to describe the quantum state of a molecule just isn't possible. Even with our largest supercomputers, you quickly get to the point where there's just too much information you need to keep track of. But a quantum computer can do that relatively straightforwardly, because we're just mapping one quantum system onto another, right? But I would say that there's applications far beyond discovering quantum systems and looking at chemistry. We also know that quantum computers can be very useful in optimization, optimization problems. So if you're trying to decide how to pack things into your aircraft or which route your truck should take, I think these are all problems that a quantum computer shows great promise as being able to deliver speed ups beyond what you can do with classical computing. I'd also say there's also applications in the finance industry. Again, a lot of the problems they're looking at there look like search problems, which there's known algorithms that speed up searching for information, or that look like optimization problems. And so I think the promise is large, and it's sort of exciting to be in these early days where we can work with these different companies to build these sort of beginning algorithms to explore it with the small hardware that we have now, and map a path to get to the point where we're solving problems that just aren't solvable on regular classical computers.
And I'm curious, are there any other partnerships or maybe use cases that you could share with the listeners today, just to help them understand how it might work in their world?
Yeah, so I think one of the partnerships we listed in the announcement or shortly after was with DHL. So they're a big logistics company. And I won't pretend to know everything they do, but the problem we engaged with them was to figure out some of these optimization issues. So the problem we bit off was how to pack different sized boxes into a shipping container, right? They're shipping things all across the world. And if they can do it more efficiently, this can save them fuel and time and ultimately money. And so they partnered with another company, Cambridge Quantum Computing. And between the three of us, so DHL, Cambridge Quantum Computing, and Honeywell Quantum Solutions, we were able to run an algorithm that showed an optimal solution for this packing problem. Now, the size of this packing problem was relatively small. It was just a handful of boxes in a very small container. But it was to show that the capabilities of the computer, and then also to help start to develop that software, which can be scaled as the capabilities of the computer increase. So we see a lot of these collaborations, often with multiple companies working on providing the domain expertise on here's what's important to our business, and then someone like Cambridge Quantum Computing who is focused on writing these algorithms, and then being able to then work with Honeywell Quantum Solutions to apply it to real quantum computing hardware, analyze the results, and map out a path forward to increase sort of the algorithmic capabilities for their use case.
And as someone that's working right in the heart of the industry, where do you see quantum computing heading in 2021 and beyond? And is there anything that particularly excites you?
Oh, I think it's such an exciting place to be at. I've read histories of of regular computing, when the transistor was first invented, and then just how fast everything sort of exploded once we had these solid state transistors. And it feels like we're at that same place right now with quantum computing, right? We've got the first computers. We have some basic ideas of what they're good at, and the hardware capabilities are just expanding very rapidly. So at Honeywell Quantum Solutions, over the next year, we're going to see our fidelities increase, the number of qubits increase. We're going to be launching more systems, so we'll have more capability to run with more customers. And so I think there's a lot of excitement just on our hardware capabilities. But I think the thing that excites me the most about this next year is that we're getting more and more people to use our quantum hardware, and as they do so, more ideas are entering the field, right? I feel like although there was a lot of wonderful work that went on trying to program computers before they even existed, you can think of people like Alan Turing or Charles Babbage who theorized about how a computer would work. It wasn't until we had one that people really started to explore their full capability. And that's what we're seeing right now in quantum computing as well, is that as we have customers from the finance industry, from the materials industry, from all these different places using our quantum computers, they're discovering new things that they can do with them, new tricks and techniques to sort of squeeze more performance out. And so we're really seeing that the capabilities of our computer are growing as we add more hardware capabilities, increasing the fidelity, adding more qubits, all of that. But I'd say they might be growing even faster as our users gain experience and figure out how to squeeze more performance out of them. It's been so fun to work with our customers and see the inventive things they come up with to really take advantage of the features we have. So it's, if you build it, they will come, and we're seeing a lot of just wonderful creative solutions coming up to take advantage of the hardware, and things I don't know I could have predicted.
Love that. And I've loved chatting with you today. Before I do let you go, for anyone listening that would like to find out more information about the work that you're doing, what's the best way of finding that information online, and also contacting your team if there are any decision makers or techies wanting to ask them any questions about the kind of capabilities that you can offer? Yeah,
so you can always just go to honeywell.com and navigate there to the Honeywell Quantum Solutions page. But perhaps even the easiest is just Google Honeywell Quantum Solutions, and that first link will pop right up to be us, and there's contact information on that page there.
Excellent. I think what's so exciting here is that possibilities of quantum computing are endless, and we don't yet fully realise or know how far we're going to go with it, and we're just learning about those kind of capabilities that we can have. And it's almost like we're exploring the art of the possible in real time, and I find that incredibly exciting. So a big thank you for taking the time to sit down and share that with me today.
Yeah, thank you. It was a pleasure to be here.
Incredibly cool, isn't it, hearing about a quantum computer from Honeywell and all the stuff that they're doing today, not tomorrow. Growing up, I only dreamt of this stuff, so I find it incredibly cool hearing about real-world use cases and how it's being used by companies such as DHL and how Accenture are using it for applications too. So a big thank you to Brian for sharing Honeywell's progress in quantum computing last year, where he sees it heading this year, and the types of applications quantum computing can be used for. And if we do have any quantum experts out there, or anyone who has some great use cases, examples, insights on how this technology will be used in the future, you know where to find me. My email address is techblogwriter@outlook.com. My website is techblogwriter.co.uk. LinkedIn and Twitter @Neil C. Hughes. If you do follow or connect, please send me a quick message so I know that you listen to the podcast, because it's not about inflating follower counts. I genuinely want to have a little chat with you all. But that's it for today. So a big thank you for listening. I'll speak with you all again tomorrow, but if you don't make it, until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.